In this video, we're going to cover Kirchhoff's rules. Up until this point, we've been analyzing simple circuits by combining resistors that are in series or in parallel or both, and then using Ohm's law. This works for simple circuits, but in order to analyze more complex circuits, we need to use Kirchhoff's rules, which are based on the laws of conservation of charge and conservation of energy. Kirchhoff's first rule, which we call the Junction Rule, is based on the law of conservation of charge. So it basically says that in any junction point, the sum of all the currents entering the junction must equal the sum of all the currents exiting the junction. So here's an example. If we take a point here, if we have, actually this is backwards, but if we say that the current I is going in, actually they're calling it I3. This would be the junction. What goes in, I3, must equal what goes out, which is I1 plus I2. Here's another junction which says that I1 and I2 have to give me I3. So we set I1 plus I2 equal to I3. Kirchhoff's second rule is called the loop rule, and it's based on the conservation of energy. The sum of all the changes in potential around any closed path has to equal 0. Okay, so that means that all of these voltage drops have to equal 0. So if we start here at the plus terminal of the battery and work our way around, we have V1 plus V2, we hit the minus, and that would be minus V. Okay, they go in the opposite direction as me. So I always go from plus to negative. In this case, I think they're going from negative to plus, and that means this would be negative, negative, positive. It doesn't matter which way you go, just understand that current is going from the plus terminal to the minus terminal. And if you go against the current, it's negative. And if you go with the current, it's positive. Okay? So if I go around this way, I'm going in the same direction as the current, so it would be plus I1 plus I2, and then I hit the negative terminal of the battery, and that would make it negative V. Okay, and you can pick any point to start. You just pick any corner of the circuit. If you go the opposite way, this way, I'm hitting the plus terminal of the battery, so that's plus V. I'm going against the current, so that's minus V2 minus V1, and I'm back where I started again. Okay, so this is the procedure for solving problems using Kirchhoff's rules. And we are going to do some of these problems in class so you can get a better idea of how it works. So the first thing you want to do is label the plus and minus terminals of the battery. Next, what you want to do is label the current in each branch with a symbol and an arrow. You don't have to worry about the direction of the arrow. It turns out that if you pick the wrong direction, the number will come out negative. Okay. Next, you're going to apply the junction rule to each junction. You need as many equations as there are unknowns. So if you have 5 unknowns, you need 5 equations. 3 unknowns, you need 3 equations. You can also use Ohm's law to reduce the number of unknowns. Next step is to apply the loop rule for each loop. Pay attention to the signs. For a resistor, the potential difference is negative. For a battery, the potential difference is positive. I don't really go by that. Cross that one out. What I would say is this: follow the current. If you're flowing with the current, it's positive. If you hit the positive terminal of the battery, it's positive. If you hit the negative terminal of the battery, it's negative. Okay, so just go by the direction of the current. This way is just going to get you wrong. Okay, then once you get all of your equations, you then solve them algebraically. This is the part where you're going to want to consider how many equations you have and whether you want to do this algebraically or not. So for instance, if you have 3 unknowns, you get 3 equations. You know that you can probably get that done in a fair amount of time. What if you have 5 or 6 unknowns? Okay, you're going to spend an enormous amount of time doing the algebra just to find the answer. You may want to go ahead and set this up as a set of linear equations and set this up in a matrix. And I will show you how to do the matrix during class time. Okay, so what we're going to do here is we're going to go ahead and find the unknowns in this circuit. We have one unknown, and that is right here, R3. Okay, so that's what we're solving for. The first step is to label the terminals of our battery. Here's plus, here's minus. The next is to label the current. I'm going to have the current I come out. Here's a junction, so it's going to split. I'm going to have I4 go up. And again, if I'm wrong, if the current's actually going in the opposite direction, I'll get a negative as my answer. And I'm going to call this I3. I have a junction here, and I have I3 and I4 coming in, and I'm going to call this I. You may be wondering, wait a minute, shouldn't you call it I2? Well, it says here I2, but look what I chose. I chose I as the current. So it turns out that the current through resistor 2 is going to be the current of the circuit. At least that's what I have here. It's a little bit more complicated than that. Okay, so the next thing to do is to apply the junction rule. At this junction here, I have I going in, and that has to equal what comes out, which is I3 and I4. Okay, so now that we have one junction, we're going to look at the other and notice that it's exactly the same thing. And again, we already know that I equals I2 because that's what they're calling it. They're calling this I2. So we can rewrite this as I2 is equal to I3 plus I4. Okay, so we've applied our junction rule. Now what we're going to do is apply the loop rule. Now in order to apply the loop rule, you have to pick a point. I always like to pick a single point and then form my loop that way. So let me show you how many loops you can have. If you choose this as your point, we have one loop here, we have one loop here, and then I can choose this point and have a loop here. Okay, so there's actually 3 loops, 1, 2, 3. There's 3 loops that I can use for my loop rule. Okay, now I just want you to know I'm going to clear all that off so that you can see what I'm going to do. I'm going to start here and I'm going to use this loop. And I'm going to go all the way around and I'm going to look at the voltage drops. I'm going to do it a little bit different than the rules of how they set it up because I want to show you how this works. Okay, so as I come this way, I'm following the current, so that's going to be plus V3. They already give me V3, so that's fine. As I come along here, I'm going to hit this resistor here, and that's going to be I3 R1. Notice that I didn't write V1. We don't have V1, but we do have I3 and we do have R1. They're given, okay? Or at least it's something I'm going to solve for. Okay, now I come along here and I go against the current, so that means minus. Now again, I want the voltage drop on this resistor, which is IR. So I'm going to have minus I4 R4. Okay, I come back here and that's equal to 0 because all the voltage drops have to give me 0. Okay, now I have 2 equations, but I have a lot of unknowns. I don't know I3, I don't know I4, and I don't know, and I need R3, so I need to solve for I3 in order to find R3. Because remember, V3 equals I3 R3. So in order to solve for R3, I'm going to need I3. That's my unknown. I have an unknown here. I know this value. I know R1. I don't know R4. So I have 2 unknowns here. Well, guess what? I have the same 2 unknowns here. So I have 2 equations, 2 unknowns. So that means I can either do substitution or elimination. So let's go ahead and do substitution. So I'm going to go ahead and solve this equation right here for I3. I'm sorry, I4, because I want I3. I4 is equal to I2 minus I3. And now I'm going to substitute this in to here. So I end up with V3 plus I3 R1 minus I2 R4 minus, let's see, actually that's going to be a plus I3 R4, and that equals 0. Okay, so now I can combine terms, and I'm going to put everything else on the other side. So I get I3 times R1 plus R4 is equal to I2 R4 minus V3. Okay, so I'm getting I3 by itself. So now I'm going to divide both sides by the R1 plus R4. And I end up with I3 is equal to I2 R4 minus V3 divided by R1 plus R4. You'll have to excuse me, I am writing with a mouse. So now let's substitute in our numbers. I2 is 2.6. R4 is 2 ohms minus V3, which is 1.87 volts. And we're going to divide that by R1, which is 5 ohms, plus 2 ohms. Okay, so substituting that into my calculator, let's see what we get. Okay, so we're going to take 2.6 times 2 minus 1.87, and then we're going to divide that by 5 plus 2, which is 7, and that's going to give us 0.48 amps. Now we can solve for R3. R3 is equal to V3 divided by I3. V3 is going to be the 1.87 volts divided by the 0.48 amps. And that gives us 3.9 ohms, or 4 ohms if you want to round up. Okay, so that's basically it. You just keep going, and what if you had 3 unknowns? Well, then you might need another loop. Okay, and notice I didn't use some of these things. So I never used the voltage of the power supply because I never needed this loop. Okay, so it gets more complicated though when you have more unknowns. Okay, so now what I want you to do is skip through all of these slides. I'm not sure what they're doing there. And now what I want you to do is go ahead and take a look at this circuit here. And we're going to solve this for the unknowns. I want you to go ahead and do this now and see whether you can use your junction rule and your loop rule. And then we'll go over this the next day in class.